Hello, my name is Keshwani. That's Keshwani, Keshwani. I have been solving math problem out of this book here, the GMAT Review, the official guide. If you do not have one, buy it immediately. You can purchase it at mba.com. The problem that I'm about to solve is the one that you will find on page number 166, problem solving number 108. Let's take a look at it. It says x and y are different prime numbers right here. X and y are prime numbers and they have to be different. We are also told that both x and y are more than 2. So I know that x has to be more than 2 and y has to be more than 2. Let's quickly talk about what they are before I look at the statements there. They are prime numbers. What's the definition of a prime number? A prime number is a number that only goes into itself and 1. Only goes into itself and 1. A prime number cannot go into anything else. For example, 3 is a prime number. 5 is a prime number. You cannot divide 5 by anything except itself and 1. 7 is a prime number. Is 9 a prime number? It is not, because 9 goes into 3. 11 is a prime number. 13 is a prime number. 15 is not. 17 is a prime number. 19 is. 21 is not a prime number. 21 will go into 7 and 3. Other than going by itself and 21. 23 is a prime number. 25 is obviously not, because it will go into 5. There is one more number which is also a prime number. There is one even number which is a prime number, which is 2. 2 is the only even number that qualifies as a prime number. Why? Because the definition of a prime number, as I said before, is that it's a number that only goes into itself and 1. Well, what can 2 go into? Itself and 1, that's it. Therefore, it's a prime number. Even though it's an even number, it meets the qualification. Which is why we're given this part. They both have to be more than 2, which means what we are dealing with are these prime numbers. And these, by definition, have to be odd numbers. Since we do not have a luxury of using 2, since 2 has been ruled out in our case, the prime numbers that we are dealing with are all odd numbers. All the prime numbers have to be odd numbers, because if they were even, it will go into 2 and it wouldn't be a prime number. The only prime number that is an even number is 2, which we do not have here. Let's look at the statements. Now this is the 1, 2, 3 statements. 1, 2, 3 statements. The question is, which of these 3 statements should I start with? This is not an insane question. It's not a question that may sound as insane, and most people look at me and say, start with statement number 1, that's the first statement. No. There are 3 statements. Start with the one that you find the easiest first. There are 3 statements. Usually one of those 3 statements is the easiest one. One of those 3 statements is a very difficult one, and one is sort of like a medium level difficulty. So I always start with the easiest one. Sometimes easiest statement is statement 1, sometimes it's statement number 3, sometimes it's 2. I'm going to start with 2 here. Statement 2 says x minus y is even. Well, let's take a quick look at it. Since both x and y in our case are odd numbers, they are odd numbers, 3, 5, 7, 11, so forth. The question is, when you have an odd number minus an odd number, is that going to be an even number? That's all they're asking. Well, let's try out for a few odd numbers. 7 minus 3 is even. 9 minus 5 is even. 13 minus 15 is a negative 2, but it's still an even number. So that is true. The first statement is true. Odd minus odd is always going to be even. First statement is true. What do I do now? If you're saying, what do I do now? If you're saying they're sitting there and saying, let's go to statement number 2, the answer is no. I do not do that. I pick one statement, I find out whether it is right or wrong, and I quickly, on my piece of paper or my scratch paper that they give you, the contraption, I write down the letter. I literally write down the letters, A, B, C, D, E. Only takes a second. And I cross out the impossible answers. I just found out that statement number 2 works. Which means any answer choice that does not have no more removal 2 in it, I'm going to cross it out, so that I do not end up picking it inadvertently. C is gone. C does not have 2 in it. And that's about all. Let's look at second statement. The second statement here says x minus y is even. Oh, sorry, third statement I meant. The third statement says x over y is not an integer. Is not an integer. Well, let's talk about it for a second. What would have happened if it were an integer? If x divided by some other number y were some integer, like say 3 or a 5 or 7 or 13 or whatever, if x divided by were an integer, which means that x would go evenly into some other number. Well, x cannot go evenly into any other number. It doesn't have to be y, it doesn't have to be a prime number. X cannot go into any number, because if x could go into any other number, x would not be a prime number. We know that x is a prime number. There is a definition of prime number, that x cannot go into any number except 1 and itself. So obviously it cannot go into y evenly, because if it went into y evenly, it wouldn't be a prime number. So that statement is true as well. Statement number 3 is true as well. Let's see what else can I cross out. So now I'm going to cross out any answer choice that does not have Roman numeral 3 in it. That rules out A, that rules out B. And if I were taking the real exam right now, and if I'm running out of time, or if I don't feel like it, or if the third statement is extremely complicated, I cannot figure it out, I'll just take my chance and move on. Pick one of the two and just move on. That's what you do. Usually by the time you figure out 2 of the 3 statements, usually you can narrow down your odds to 1 out of 3 or 1 out of 2. On a lucky day, on a good day, maybe you can even cross out 4 answer choices depending on which 2 that you start out with. It's just a matter of luck. But do not start out necessarily with 1 unless you find statement number 1 very easy to work with. Let's look at statement number 1 now. Statement 1 says, x plus y cannot be 91. Well, x we know is an odd number, y we know is an odd number. So the question is, can odd number plus an odd number be an odd number? That's all they're asking here. Can 3 plus 5 be an odd number? Answer, of course, no. If you have 2 odd numbers, x is an odd number, y is an odd number. How do I know x is an odd number? Because I'm told that x is a prime number. And therefore it has to be an odd number, because the only prime number that's an even number has been ruled out. Here. That's hence the significance of this statement. Y also is an odd number, because y is a prime number more than 2. So that means it has to be one of these numbers. So the sum of 2 odd numbers cannot be an odd number. That statement is true. The sum of 2 prime numbers. The sum of 2 prime numbers cannot be an odd number. That statement is true. 91 has no significance here. 91 is just there to throw you off. It has no significance. All they're saying is that if you add up x and y, it cannot be an odd number. That's all they're saying here. That's all. So the third statement is also true. So the correct answer here is answer choice E. E is the correct answer here. D also is ruled out. That's all. Listen, if you find this helpful, if you wish to buy my DVDs that I have put together, which contain the solutions to all the problems in this book, send me an email. Go to my website at www.prep.gmat.com. Send me an email, or if you wish to hire me for personal private tutoring, again, send me an email. Go to my website at prep.gmat.com. I am located in Connecticut, and we'll talk. All right? Thank you.